Okay, we're on trigonometric integrals too. So here we're going to find the integral of the following inverse trig functions. So let's start with this first one. To solve this, we need to use integration by parts, yes. And if you could remember that we have that integral of u dv is always equal to uv minus integral of v du. So the major problem here is which one is u and which one is dv. So you always use leap day to know which one, where L is the log function. If you see any logarithm function, I is inverse trig function, polynomial, T is trig, and finally E is exponential function. So that's the order of u. So in this case our u is from this, it seems we are given only that, but in the real sense our u is this, why our dv is 1 dx or dx. So we're applying it now. So this is u, why our dv is dx. So integral of u is sine of x, and v is dx. If you integrate dx, you have x minus, so sine x times x minus integral of v, so v is x, and if you differentiate du, dx is, if you could remember, is 1 over square root of 1 minus x squared. So if you've not watched the one, that's trigonometric integration 1. If you don't watch the other video on this, integral of arc sine, you better watch before this. So the x, so this is my du, why this is v. So this is now equal to, let me write x first. So x of x minus the integral of this. We start again. So which one is u, which one is dx? So minus, we have x over, that's integral of that, square root x squared dx. So the major work is this, but if there is one formula that integral of fx and f prime x dx, the integral of product such that one of the function is the derivative of the, and one of the function is the derivative of the other one, the answer is just fx n plus 1 over n plus 1 plus k. So that's how, that if you notice that the derivative of one of the functions is the other function, so that's what I will use here. Because if you notice, if I differentiate 1 minus x squared, I'll have minus 2x. So meaning that I can write this as, we are solving that integral of sine of x dx is now x arcsine of x minus integral of x over square root 1 minus x squared dx. So I can write this so that I can easily see that is of that form, this form I just showed you, integral of x square root, so we can write this as 1 minus x squared raised to power minus half. dx. So which is correct using laws of indices. So if you notice, this is 2, this is, if I differentiate this, I have minus 2x. So I can write this as x sine of x minus, or maybe plus half integral of minus 2x. Maybe let me write this first, okay? Integral of 1 minus x squared raised to power minus half times 2x, that's times minus 2x, times minus 2x dx. Have you seen it? 2 plus times minus, I have minus. So I have this form now. My fx is 1 minus x squared, and is minus half. Just compare. You see it, because this is the derivative of this. So my n is minus half. My fx is 1 minus x squared, while f prime x is minus 2x there. So we can easily see that this is now equal to x sine of plus half. I now do 1 minus x squared minus 1 over 2 plus 1 over minus 1 over 2 plus 1. That's our n is minus half. So that's it, plus k. So let's finish up. That's our answer. So we have x sine of x. 1 minus half is half. You get? This over half is now 2 times that. So 2. So we are left with 1 minus x squared raised to power half plus k. Do you get the 2 here? That's half reciprocate, so 2. So that's it. That's the answer. Or maybe we can write it as, we say that integral of x and of x, the x is now x sine of x plus, see what I want to rewrite this as square root of plus square root of 1 minus x squared plus k. So that's it. So if you've seen anything of this form, that's the answer.